Hey guys, let's discuss new problem from dynamic programming, which is called find the minimum cost climbing stairs, which is the extension of the earlier problem, which was climbing stairs. Okay, so here instead of finding different ways to reach till that particular stair, you need to find the minimum cost to reach there. Okay, so for example, last time what we were doing, like if you're at stair and if you wanted to check the number of ways, okay, minimum means number of ways to reach till this stairs, you were finding n-1 and n-2, the total number of ways for n-1 and n-2, and then you were just doing summation of that. Okay, if you not watch that video, please go and check the earlier video, which is climbing stairs in dynamic programming. Okay, so now here instead of finding both the summation, what I will do, I will find that what is the minimum cost between these two, n-2 or n-1. I'll take that because here I need to find the minimum cost and not the all the ways, right? And plus whatever cost for this cost n. So this one will always become. Okay, so how I will do that, and the condition is same, either you can jump to one step or two step. Okay, so so for example, if the cost array is given something like this, cost array is given 10, 15 and 20. So it means that if you're at stair 0, okay, let's say this is 1, this is 2, and let me create one more. Okay, if you're at see here two conditions. Okay, if you wanted to reach till 2, so either you will be on stair 1 or you will be on stair 2. So let's say you're on stair 2, here stair 0. Okay, so what is the cost of stair 0? It is 10. Okay, so I'll take 10 here, and then from here you will jump to 2, correct? So what will be the cost of 2? Cost of 2 will be 20. Now similarly, if you're at stair 1, the cost of stair 1 is 15, and from here you can jump only 1. So which is, and the cost of stair 2, 20, stair 2 is 20. So here this one will be means in both the cases, okay, you will calculate this cost of 20. So 20 plus, now whatever is minimum for 0 or for 1. If you're standing on 0, that one is minimum, or if you are standing at 1, that one is minimum. Okay, n-1 and n-2. So for 0 it is minimum, so I'll take this 10. Okay, so 30 will be my answer. It means that I'm standing at 2, and then from here I'll jump to 2 steps, so that one will be my answer. So this is what you need to find. Okay, very simple. How you can do that, you just find the recurrence relation. Okay, and so what will be the recurrence relation here? See, the base condition, you know that dp0 will be cost 0 and dp1 will be cost 1, whatever is on 0 or whatever is on 1, right? This one will 0 and 1. Why 0 and 1? Because at a time you can jump to 1 step or 2 step. Okay, in question they have not given 3 steps, only 1 step or 2 step. That's why I have taken first two element from the array. So I have given it as dp0 dp1. Okay, I'll create one 0 1 2. I need to reach till second, so 0 and 1 will be my this one 10 and 15. Okay, now what is the cost of reaching 2? So the cost of reaching 2 is whatever is cost for 2 plus minimum of, okay, minimum of dp0 or dp1, correct? So this is 10 or 15, whatever is minimum, and here it is what was it, 20. So 20 plus 10, 30 will be my answer. And if you need to write it in a recurrence relation, so how you will write it, dp of I, okay, for this dp of I, which is now 30, the cost of I means whatever here, this one 2, okay, cost of I means this 2, 20, plus whatever is minimum, dpi minus 1 and I minus 2, and then at the end you will find dpi, and at the end you will find whatever is minimum, dp n minus 1 or n minus 2, the last one, right? Last one and last second one. So and if you wanted to do space optimization for this, see, first of all, it's time complexity will be order n, space complexity will be order n, because you have taken this dp array, right? This dp array. But if you wanted to optimize the space here, so don't take dp array. Okay, instead of dp array, just take two variables, previous one, previous two, because at the end we need to use last two elements only for the calculation and not for the entire array, right? So you can replace entire array with two variables, which we have seen in last all the problem of dynamic programming 1D array, right? So previous one, previous two you will take. So in this case your time complexity will be order n, and space complexity will be order 1. So that's it. Thank you.